In this section, chapter 3.1, we're going to be studying quadratic functions. In particular, our objectives are graph a quadratic function written in vertex form, write the function f of x, ax squared plus bx plus c in vertex form, find the vertex of a parabola using the vertex formula, solve applications involving quadratic equations, and create quadratic models using regression. Our first objective is to graphing quadratic functions. In the past, we've talked about the graph of the quadratic function, which is fx equals ax squared plus bx plus c, where a is not equal to 0 and is a parabola. The parabola opens upwards for a greater than 0 and opens downwards for a less than 0. As you can see, if a is negative, we would have a graph that looks like this. If we have a that's a positive x, we have a graph that looks something like this. Our second objective is the vertex form in completing the square. The function may be written in vertex squared form as follows. F of x is equal to a times x minus h squared plus k, where the vertex is h, k. Notice we've talked about this in the past sections. The axis of symmetry has to be at x equals h. Well, where is that? That is where we have the axis of symmetry going through the vertex. This is called the axis of symmetry, and this is at x equals h in both cases. So in our first example, we're going to graph the quadratic function, identify the vertex, and x and y intercepts, and the axis of symmetry. I would like you to pause the video at this point and see if you can find the vertex, find x and y intercepts, and the axis of symmetry, and graph this function. So please pause now. So our first step in any quadratic is to find the vertex before we graph. So to find the vertex, we notice that it's in squared form. So in this case, we have x is 3 and the y coordinate is a negative 9. So there's our vertex. Now we want to find the x and y intercepts. Well, the easy one is to find the y-intercept. For the y-intercept, we just let x equal 0. So when we have x equals 0, we have 0 minus 3 squared minus 9. And in this particular case, we have 9 minus 9, which is 0. So our y-intercept is at 0, 0. The next step is the x-intercept. Well, in this case, we let y equal 0. So that means 0 is equal to x minus 3 squared minus 9, or 9 is equal to x minus 3 squared, or plus or minus 3 is equal to x minus 3, And in this particular case, the x-intercepts are at 0, 0, or they are at 0, 6. Or actually, I have it reversed here. Sorry. It's 6, 0. So let's graph. The vertex is at 3, minus 9, so I go over 3 and down 9. 1, 2, 3, 5, 6, 7, 8, 9. So there is our vertex. And our axis of symmetry is also at 3. And now we will plot our x-intercepts, because our x-intercepts are at 0 and at 6. So really, here's our graph. There we go. So I'd like you to do this problem, example 2. Again, f of x is equal to a minus x squared minus 2 squared minus 1. So pause the video and find the vertex and x and y intercepts, and then the axis of symmetry and graph. So after you've paused this, now you can look at what we did. We had the vertex is equal to at 2 minus 1. The parabola opens down. This is an important feature. Why does it open down? Because there's a minus x in front of the squared term. The y-intercept is at 0, negative 5. And when we did the x-intercept, we found that there were no x-intercepts because we got a complex imaginary number. So now we can graph. So we go to our vertex, we go 2 over and 1 down, which puts us right here. And now we will look at my y-intercept, because once I have a y-intercept, I know I have an axis of symmetry along x equals 2. So we'll put it at 0, minus 5. 1, 2, 3, 4, 5. We have a point here, and we have a point equal distant on the other side of the axis of symmetry. And so now we have a parabola that looks like this. Suppose we don't have a quadratic equation in squared form. Can we find it in squared form such that we can identify the vertex relatively easily? So example 3 is using the technique of completing the square to writing fx 2x squared plus 20x plus 42 into a vertex squared form. And then we can identify the vertex. So the first step is to factor out a 2 in the x terms. So what that means really is the following. So I have f of x is equal to 2 times x squared plus 10x, parentheses closed, plus 42. That's our first step. Our second step is to actually complete the square inside the parentheses. So we have a 2x squared plus 10x, take half of 10 and square it, which is plus 25. Oh, but now what do I have to do? Well, here's the step. Because we have a 2 here and we have a 5 here, and we added 25 inside, but we had to multiply it by 2. We've added 50 to this side of the equation. So we have to subtract 50 out. So our next step, essentially, once we've done that, is the following. So now, because we factored out the 2, now we can bring out and complete the square part of this form. So now we could probably read the vertex quite easily. So now the vertex is at -5, -8. That's it. So now it's your turn. Write fx equals -x squared minus 2x plus 3 in vertex form, and graph the function. Identify the vertex, x and y intercepts, and the axis of symmetry. Then graph. Identify the domain and range. So I would like you to pause now and try the problem. So here we've done the problem. We will go through it real quickly. We have set up taken a negative out of the x squared and the 2x term, and we see that we have, oh dear, I've made a mistake already. So hold on. We have to change this, right, to a plus. There's where our mistake is. This is a plus. We still have a plus here, but now we have a +1, don't we? Right? And so now the vertex is at a -1, 4. So we do have to change something here. We have a +1 down here and a +1 here. Okay, so that makes this is a +1, so that makes it a -1, but even if it's a -1 on either side, we get a -3 and a 1. So these are correct. So notice that we have to subtract a 1 out, we have to add a 1, right? So that didn't change, right? So we have an internal completing of the square, so we've got that. And then we've got a completion of the square, which is a negative x plus 1 quantity squared plus 4. And now that gives us the vertex at -1, 4. And now we have the intercept, and the intercept is at 0, 3. When we put a 0 in for x. And the intercepts actually, there's 2 of them, at -3, 0 and 1, 0. So now we can graph our graph. So the vertex is at a -1, 4, right? 1, 2, 3, 4. So we are right here. Now, does this open down or up? Well, guess what? We have a negative in front of the x squared term, so it has to open down. We can look at our y-intercept, or we can look at x-intercepts. Our x-intercepts are at 1, and it's at -3. 1, 2, 3, right? So our graph goes in this direction, right? There we go. So our third objective is to use the vertex formula to find the vertex of a quadratic. So for a quadratic, f of x is equal to ax squared plus bx plus c. the coordinates, the x-coordinates of the vertex is given by x equals a negative b over 2a. This is called our axis of symmetry. And so this is going to be used to evaluate the vertex because that's the x value. And to find the y-coordinate of the vertex, we just input the value we found for x for f of x. And so the vertex is given by a negative b over 2a, comma, f negative b over 2a. So let's see how this works in practice. Here we are given a function, a negative 3x squared plus 48x minus 165. Determine the vertex by using the vertex formula, and then by writing it in vertex form. Well, in some sense, we can use the formula to find the axis of symmetry. X is equal to a minus b over 2a, which we've known for a long time. And here we have a minus 48 over 2 times a minus 3. And this is 48, a negative 48 over a negative 6, which is just 8. So our vertex at 8 is, that's where the axis of symmetry is. Now we'll find the y value. And when we find the y value, we'll put in minus 3 times 8 squared plus 48 times 8 minus 165, right? And so when we do all of that particular work, we'll end up with 27. So now our vertex actually is, guess what? 8, 27. Oh, I see I made a mistake. I put down 25, and it's really just 27. So there's our vertex. Okay. Now, if we want to write it in vertex form, we know that this is going to have to be it's going to have to be in this form, right? It's got to be in the form x minus 8 squared plus 27. It has to be in that form, right? Well, we know that we have to have a negative in front of the x squared, but not only that, we have to have a negative 3. And the reason for that is that even though we've already found the vertex and we can put it in the vertex squared form, because of the fact that there's a negative 3 in front of the x squared, but when we take the negative 3 out, we know that we can complete this square by x minus 8. Okay, and we'll end up getting a 27 anyway. So this is the squared form, vertex form, that we would normally use, but this is the other way of getting the vertex as well. So here we have an application. At the end of his career, Sherlock Holmes retired to a small farm in the country and took up a hobby of beekeeping. Being of an analytical mind, he could not just watch a bee fly from flower to flower. He formulated a mathematical model for the parabolic path the bee follows from flower A to flower B. The path is given by the following. F of x is equal to a negative 0.03x squared plus 1.8x minus 24, where x is the distance in inches along the ground from Sherlock. So Sherlock is at the origin, and then the B is from A to going to B. So the first question is what is the maximum height the bee reaches as it flies from A to B? In other words, what we want to do is we want to find this distance right here where the maximum is at the vertex. Oh, I said something important. At the vertex. So what we're going to do is we're going to find the maximum height based on the vertex. So the first step is find the distance at the max. So we're going to find the distance from here to here from the max. That's the x term, and that's where the axis of symmetry is. And so now we can say x is equal to a minus b over 2a. And in this particular case, it's a minus 1.8 divided by 2 times a negative 0.03. And when we do that math, we get 30 inches. Okay, so x is at a maximum at 30 inches, but that's where he's at. It's not the maximum height that the flower reaches at this point here. So to find that, we have to find y. And to find y, we just put in the 30 inches. So we get a minus 0.03 times 30 squared plus 1.8 times 30 minus 24, and this gives us an answer of, if we did this correctly, 3 inches. So the maximum height the bee goes up from flower A to flower B is about 3 inches. Now the next question, which we will get to in just a second. So the next question is how far away from Sherlock are flowers A and B? Well, we notice that they're at a origin point of 0 from Sherlock. So we set the equation above to be 0. So we have 0 is equal to a minus 0.03 x squared plus 1.8x minus 24. Now we solve this for x, and because it's a quadratic, we're going to get two solutions. We're going to get a solution at A, how far he is from A, and then how far he is from B. So from this standpoint, we get, when we divide through by a negative 0.03, we get 0 is equal to x squared minus 60 plus 800. So now we get a negative 800 is equal to x squared minus 60x, and now if I complete the square on the right hand side, we will get 900 minus 800 is equal to x squared minus 60x plus 900, because I took half of 60 and I squared it and I added it to both sides. So now we get 100 is equal to x minus 30 squared. So when I take the square root of both sides, I get plus or minus 10 is equal to x minus 30. And so we get 30 plus or minus 10 is equal to x. Notice the 30 is right at, where is it at? It's right here at my axis of symmetry. So in some sense, x is 40 inches away from Sherlock. That was at B. And at A, we are 20 inches away at flower A. So here's a very interesting problem. A farmer has 200 feet of fencing and wants to build 3 adjacent rectangular corrals. Determine the dimension that should be used to maximize the area and find the area of each individual corral. Well, the first step is to find the perimeter of all of these different corrals. So in this case, the perimeter, right, which is 200 ultimately, is 4x plus 2y. Do you see why that is? Notice we have a y here, we have a y up here, and we have 4 x's. And that has to be equal to 200. So one of our equations that we're going to use is 200 is equal to 4x plus 2y. And in fact, we can divide by 2 and we get 100 is equal to 2x plus y. So that makes life a little easier because now we can solve for y directly. Y is equal to 100 minus 2x. Okay, so far so good. But that's only one of the equations. The other one is area. Well, the area, the total area that we're going to be looking at we're going to look at each one of the corrals, but in this particular case, we have y times x is the entire and total area that we're looking at. One of the x's that we would be looking at, if we were just looking this is divided by 3, we could say one area of a corral really is x times y divided by 3, right? Because it's 3x over y, right? Or we could even state it better than that. We can say that 3 of the areas is equal to x times y. Well, now what can we do? Well, we can guess what? We can plug this in for y, and we have 3 areas is equal to x times 100 minus 2x, and now the 3 areas is equal to 100x minus 2x squared, right? And so now I can do one other thing, right? I can say, well, I can divide area out by 3. I can get, this is a minus 2x squared over 3 plus 100 x over 3, and now I can find the maximum area. Well, you say, well, how do I do that? Well, remember the maximum area has to be at what? X has to be at a negative 100 thirds divided by 2 times a negative 2 thirds, right? So x has got to be what? Well, we have a negative 100 over 3 divided by a negative 4 over 3. So x has to be equal to 25, right, feet. So if x is 25 feet, we can always go back and find y, because we have a idea that that can happen. So now we can plug this back into that equation, and so now y is equal to 100 minus 50, so y is equal to 50 feet. So now we have found the dimensions for each of the corrals, right? And so if we multiply those two together, we should get the answer of 416 feet, I think, but maybe not. That gives us, oh, that gives us the total area of y, though. See, each one of these are 25, but we have to divide 50 into 3 to get for each area. So we can multiply 25 times 50. That gives us the total area. So each corral, right, each corral is equal to 50 times 25 divided by 3, right? And that makes sense, which is 416.8 feet approximately, right? So our calculators are able to find a data set, a model for a quadratic function if we know what a quadratic function looks like. So here we have a data set in example 7, and we're going to plot this data set using the calculator, and then we're going to fit the best quadratic model to the data set using our calculators. This is an amazing thing for calculators to do. In the old days, we had to do this stuff by hand, and so we will go to the next example. So what we end up doing is we use the Stat button on our TI-83 or 84 and then hit the Edit key to enter in the X and Y data set. And so we'll put the X data set from the table that we had in the previous screen into L1. This is our X data set, and this is going to be our Y data set. So we go from a screen that looks like this to putting data into here. Now we will exit this screen, and we'll show you the next operation after you've entered the data. Once the data has been entered, we can use the Stat button key again on your TI-83 or 84 and then move the icon over to the Calculate icon. And then when you see this menu screen, you are going to select option 5, which is Quadratic. When you hit enter, you're going to see on some calculators it'll ask you for an X list and a Y list. For the X list you'll put in L1, and the Y list you'll put in L2. For those that do not have the X list Y list function, you'll just, when you see the quadratic, you'll put in L1 comma L2. So now once we picked quadratic and we have this option, we'll choose L1, which is second one, comma, which is above the 7, L2. And then we'll hit enter. When we hit enter, we'll get this screen right here. And you'll notice that this is the quadratic form of the formula, and that these are the coefficients of the quadratic quadratic regression line of ax squared plus bx plus c. So the equation here is this equation right here. To see the data in the line graphed, there is a key above that's called the y equal key. This y equal key is right below your graphic screen on the left hand side. When you press that key along with the second key, you will get this menu screen below you. So you have to hit the second key and the y equal key to get the screen stats plot. Then you select option 1. From option 1 you'll hit enter and you'll get to this screen here, which is the one on the right, and you'll click the icon to on and you'll move your cursor down to where it's covering over this particular icon. That's called the scatter diagram icon. Then again you'll put your X list at L1 and make sure that your Y list is in L2. And it doesn't really matter what your mark is. You can have a plus or a square. It doesn't matter. And then what you're going to do is go to the Windows key next. The Windows key is right next to the Y equals key. And you have to set up your scale for X and Y. You have to set up your scale for X and Y. And so that's the minimum values of X to the maximum values of X, to the minimum values of Y to the maximum values of Y. Make sure your scales are correct. And then after that, we will show you the next screen. When you hit the graph screen, which is the far right hand top button, it says graph on it. When you hit that, you will get a screen. If you've set up your X and Y scale correctly, you will see this particular format. Notice it very much looks like a quadratic. Okay. But now we're going to plot a line through that data set using the regression line that we had found from the calculator. So now when you enter in, when you hit the Y equal key again and you'll choose Y1, you'll just enter this equation into the Y1 field, right? There is an alpha key that automatically puts the X in, and you can see how they did it. They did negative 0.034X caret 2 plus 2.793X, which is the alpha key again, minus 14.285. Once you've entered this in, you hit enter and you get your cursor down to Y2. Then you can hit graph. When you hit graph, you will see the line going through the data points. We can do the same thing in Excel actually, and if you wanted to, we can show you in Excel how this is done, but in Excel we can also show you that you can set up the data set for X and Y, and you can find a regression line for the data. It would be approximately the same number for the data that was done on the TI 83 and 84. Well, that concludes our section on quadratic functions, and I would like you to go in the book and look at the problems and also look at the problem sets of the day.